Hello. Okay, are we good to start? I hope so. Okay. Yeah, so hello, I hope everyone's nice and awake after that coffee break. I'm just going to be doing a fairly quick summary of what we've been up to in the PulseAudio world. For those of you that don't know me, I'm Arun Raghavan. I work at Collabra. I'm one of the upstream PulseAudio maintainers, and I work on PulseAudio, GStreamer, and, well, whatever else takes my fancy. Right. So the last time we met, it was the GStreamer conference in Prague in 2011. We had just released PulseAudio 1.0, and we were ready to take over the world. What have we been up to since then? Right. We now actually have something that approximates a release cycle. We've had 3 major versions since 1.0, so, and we've got a 5.0 impending, so that's been going reasonably smoothly. We're not actually stuck to the release schedule that we created, but we're not terribly far away from it. We've had about 1,000 commits since then, and this has come from about 70 contributors. So from the perspective of the community, we seem to be doing okay. It's fairly healthy. In terms of commits per month and the overall lines of code count, we've been fairly stable. So if you look at Olo and look at the graphs, it's fairly stable compared to 4 or 5 years ago when development was very active and lots of stuff was landing. So this is sort of a good thing and a bad thing. It's good because we've sort of got to a point where things are working, and we don't need to do any sort of major sort of replumbing to get things working. And it's also good if you're trying to build stuff based on top of this. So you know that what we have now is probably not going to be radically different from what's going to be there in a year or so. The flip side is also that we're not really making massive changes. And I mean, it's not like we're perfect and we've got everything solved. So it might be nice to be able to have that higher as well, but that's just a reflection of what the situation is. It's not like something we can actively modify. Right. There is one small problem, which is our patch review backlog, which is currently massive. There's basically 3 of us that are more or less actively monitoring it, and there's more patches coming through than we are able to actually review. So it would be nice if we had anyone from the community stepping up to help with reviews. You don't necessarily have to be very well-versed with the PulseAudio architecture. It's always nice to just have a fresh pair of eyes looking at stuff, both at the patches and the context in which they are. Yes, and anyone who volunteers will be plied with beverages of their choice. Right. So, okay. So now I'll just talk a bit about the new features that we've been working on that we've already got in since in the last 2 years. This is a fairly high-level view, and yeah, if there's ever anything that's not clear or you want to ask questions, please feel free to interrupt me. You don't have to wait till the end. So yes, one of the things that was added that we were talking about in the last update was alternate sample rates. For basically, if you're doing audio, you typically see streams that are either 44.1 kilohertz or 48 kilohertz or some approximately integer multiple of those. And on most desktop class hardware, at least, your devices can actually play either 44.1 or 48 natively, if not more formats. So a nice feature that we added was the ability to change what rate we're opening the device at based on the streams that the client requests. So if a client wants to play 44.1 and the conditions are right, we open the device at 44.1. If a client wants to play at 48, we open the device at 48. If the client wants to play 24 kilohertz audio, we open the device at 48, and we can do a much lighter weight sampling than 24 to 44.1. So this was a nice feature to have for power savings. Right. Then we added jack detection, which was a pretty large missing piece. The point of jack detection is to know when a headset jack or a mic jack or something is plugged in. And then you can do a bunch of nice things. We added the ability to store volumes on each port. And so now you can actually have your speakers at a separate volume, and then you plug in a jack and we switch the port, and there's a separate volume for headphones. So you don't have the same volume, which was kind of not a very nice thing to deal with before this. We also moved, if you're using GNOME or Unity, you would have seen that the interface that we provide is also now more focused on the actual physical outputs, the ports, than it is on sinks and profiles and stuff like that, which is quite nice from a usability point of view. So that was another thing we worked on. We added a bunch of changes to improve the voice call experience with PulseAudio. We'd already added infrastructure for echo cancellation. What we did is we improved this by ripping out the WebRTC echo canceller that Google open sourced. And we also introduced noise suppression, automatic gain control, and things like that, which in general, if you ever made calls with empathy, which I'm not going to ask how many have done that because it's probably a very small number, but if you ever did make a call with empathy, you would be quite impressed with how well that works now. We added ALSA use case manager support. For those of you who are not familiar with this, on embedded device, okay, if you've ever opened your ALSA mixer on your card on the desktop, you would have seen like a flood of mixers, which is quite painful and confusing. If you've ever done that on an embedded device, you would probably start crying because it's a lot more than even on your desktop. The last device I saw had over 250 mixer controls, and that gets a little hard to deal with the way we do on the desktop. On the desktop, we actually just look at all the mixers and try to guess what order they're in and which ones we should tweak for what. So the ALSA folks came up with this configuration format called UCM, and that basically lets you kind of describe what the hardware can do using sort of a top-level use case configuration, and then you can say these are the devices I have. So you can have a hi-fi use case and say I have a headphone device and a speaker device, and so enumerate these devices. And we added infrastructure to take those concepts, map them into PulseAudio, and then use that configuration to set up PulseAudio on your embedded devices. So yes, so that allowed us to deal with porting PulseAudio to embedded devices in a nicer way, which brings us to the next point. Excuse me. We did a port to Android. We basically did this on the Galaxy Nexus and did some comparisons with AudioFlinger, and we found that, in our completely unbiased opinion, PulseAudio was better. Right. So yes, so we did a bunch of comparisons in memory and CPU and found it comparable. And with PulseAudio, you can do a number of things that you can't do with AudioFlinger, including network streaming, hardware volumes, a bunch of things like this. So that was one thing we worked on. Incidentally, we also did a port to the Nexus 4 recently. Not all of it is sort of cleanly available in a single place yet, but that should also not be too hard to push out. And I believe David's got configuration for the Nexus 7 and the Nexus 10. So it should be fairly easy to get PulseAudio working on any of the current Nexus devices effectively. We got a bunch of neon optimizations, which are also pretty cool to see. So we have neon optimizations for software volumes, for remapping, for sample conversion. So basically our story on ARM is kind of nicer now. Oh yes, another thing that happened last year is we participated in the Google Summer of Code. We managed to get 3 projects done last year, excuse me. First of these was the ability to have a configurable latency offset on each port. So this basically allows you for things like Bluetooth, where you don't necessarily know what the latency to the device is. Say you're playing music to it, and you're playing a video where the sound is going to the headset or to the speaker or the headset or whatever. You don't know the exact latency to that thing. So what you can do is sort of manually add or subtract some latency from, from what is reported, so that you can kind of set up lip sync to work in this kind of environment. So that was one of the projects that we did. The other one was desktop notification support. I believe this hasn't been merged yet, but the idea is that there are cases where you want to be able to emit a notification from PulseAudio and possibly have some sort of user action take place. So for example, on Android, for example, you may increase the volume past a point, and it asks you for user confirmation saying, hey, please be careful when you're increasing the volume past this level. And that's one thing you can do. With pass-through, we actually have a few cases where we might want to tell the user there's a pass-through stream blocking a normal stream. Do you want to do something about it? Things like that. So we have infrastructure for that with that project. We did a third project to improve our automated tests and our logging infrastructure. Most of this was merged. There was some stuff that's still pending. But yes, so our automated testing got quite a bit better in this process. So, and we added some more options for logging that make debugging quite a bit easier. So that was one more. This is after the Summer of Code, if I remember correctly. We got a contribution to add infrastructure for volume factors. So what this is basically you have cases where you want to apply a volume on a stream, possibly temporarily, and you don't want it to be reflected in the UI. So for example, the ducking module, which is basically you have, say, you're playing music and an event notification happens. You want to be able to say, reduce the volume of the music, play the notification, and then restore the volume of the music. To do that, till this infrastructure was added, what you'd do is you'd set the stream volume, and if you have the volume UI open, suddenly the music volume decreases, and then you play the event sound, and then it increases, which is not very nice, especially when you start wanting to do more complicated things like ramps. So we added infrastructure where modules can add a volume factor that is not shown to the UI. So the volume factor is just applied, and you can add multiple volume factors that stack, and you can remove one at a time. So that was another useful feature that was added. Recently, we have been seeing some work to move to BlueZ 5. There was quite a bit of work that was done during that was also for generally cleaning up our BlueZ infrastructure and just making everything sort of cleaner, more easily maintainable, more easily readable. This is not in a release yet, but will be soon. We also participated in the Summer of Code this year. We had a couple of projects that were completed successfully. The first of these was a rewrite of Module Tunnel. The Module Tunnel basically was used to, the PulseAudio architecture works so that clients talk to the PulseAudio server via a custom protocol that we have, and we we added the tunnel module to let you talk to a remote PulseAudio instance, like tunnel the PulseAudio protocol via a network. All the tunneling code was in a separate, was kind of a re-implementation of the protocol because we didn't need everything that we were doing in the protocol initially. But this kind of became a maintenance nightmare. We'd end up making changes to the protocol and then forgetting about the tunnel protocol, and then stuff would be broken. So we just rewrote the entire tunnel module to use the native protocol, the single native protocol implementation that we have. So that was a bit of cleanup over there. Excuse me. And the other project that we had was refactoring of the resampler infrastructure. So we had a student who basically made the entire resampling infrastructure a lot more modular. So you can add new resampler implementations easily, and we've actually added a couple of them. He also added a few tests for testing the performance and the quality of resampler implementations. So it's easier on a new platform especially to kind of run this test, see which resampler works well, which doesn't, and then choose a resampler. And we're hoping at some point to be able to potentially even do this automatically the first time you run PulseAudio. We've not completely agreed on what the best way to do this is, but it would be nice to say, okay, I'm running on a system on which the default resampler doesn't work very well, and maybe you choose a less CPU intensive, maybe lower quality resampler, but one that actually does work. Yes, so that was most of the changes, the big changes that we've done over the last couple of years. We have had quite a few smaller changes all over the place. So, yeah. So, yes, that was the last 2 years. Now, what would we like to do next? A lot of this is speculative, and I mean, none of us currently have the time to sit down and do this in like the near future, but these are the kinds of things that we would like to be doing. At the Audio Mini conference on Monday, there was a lot of talk about compressed output. The idea is that most current embedded hardware, or at least the newer generation, has the ability to do decode and render completely independently of the CPU. So you have like a DSP block or like a decoder block where you just feed it MP3 and forget about it. It just gets played out. And the idea is to save CPU, especially when your screen's off. There's also API for this, I believe, that will be upstream eventually, and it would be really good to be able to do this in PulseAudio as well. So that's one thing. The second thing that I've been harping on about for quite a while is the ability to do effects, to be able to say add effects on a per stream or a global basis. And something that came up in the miniconf day before yesterday is also the ability to offload those effects to a DSP or whatever that is, like whatever you have available. The third thing that we've not completely agreed on how to do is configuration. We do want to do a bit of a revamp of how our configuration files are, possibly go to a simpler INI-based format. And something that I would like to see that we've not completely agreed on is also the mechanism for from the client side to set specific configuration, various things like module parameters, what modules are loaded, other such things. I think this would be good infrastructure to have to be able to do a bunch of things. On low latency, I think we have quite a bit that we can do to decrease the latency we have. David's done quite a bit of work to make things more reasonable than they were. But there are a number of things we can do to decrease the minimum latency we are able to achieve. Tanu and the folks at Intel have been working on a new routing infrastructure that is based on nodes. So you'll have a much more generic way of expressing the hardware that you have available and the streams that you have available, and you have a more expressive format to say how you should connect nodes to each other, and also add new features. Well, it's sort of abstract away some of the stuff that we were doing. So if you wanted to connect a source to a sink, you'd have to load a loopback module. And we'd like to sort of have the ability to let clients say, hey, just connect this to this, and have our sort of a routing sort of middle layer that does all the bits for you, all the management of those things for you without you having to do it yourself. One thing that came up on the mailing list during the previous year's Summer of Code discussions, actually this year's Summer of Code discussions, was our RTP modules. We sort of have an RTP stack in PulseAudio, and it's not got a lot of love in recent times. And I'm increasingly convinced that we should just not have an RTP stack in PulseAudio at all. And we've been thinking that maybe it makes sense for us to just defer all that to sort of push that out and use GStreamer's RTP stack. So you can just basically get PCM data and set up a GStreamer pipeline and use that for RTP, because that's a much better maintained stack. And possibly then we can also look at reusing that infrastructure to do compressed output on the network. Again, these are just ideas we've had that need to be fleshed out a bit. In the GStreamer side itself, one thing that's pending is actually supporting reconfiguration. So this is especially useful for example, pass-through cases, or if we supported compressed audio, where you set up a pipe, you decide that, say for example, you're connected on HDMI to a receiver that does AC3 or DTS. You can create a pipeline that basically just does IEC 61937 payloading of AC3 and just sends it out to your receiver directly, so you're not doing decoding on the CPU. But for example, if you move that stream, or you unplug your HDMI receiver and you want to play it on your laptop speakers, that's not going to work anymore because your speakers don't play AC3. So you need to be able to reconfigure your pipeline to insert an AC3 decoder in between. We did this with a bunch of not very pretty hacks in 0 to 10. So in 1.0, we do have all the infrastructure to do this cleanly. Just needs to be done. Right. And we're pretty much at the end. Basically, if anyone has any specific feature requests, yeah, talk to us. Now is not a bad time. And yeah, that's pretty much all I have. Any questions? Nothing. Excellent. Right. Thank you.